In the next series of videos, we're going to be looking at topic 2 in the EDEXCEL additional chemistry course, which is called Ionic Bonding and Analysis. So it's going to be 4 videos long. The first video is going to focus on ionic bonding, what it is, why atoms do it, and how we can show ionic bonding. So the first question we need to ask ourselves is, why do atoms want to form bonds in the first place? And it's really important we get our heads around this, because it ties in both with ionic bonding and with the other 2 types of bonding we're going to look at in further videos. So the absolute basics then, all atoms want to bond in order to get a full or an empty outer electron shell. Okay, so atoms are only happy, they're only stable if they've got a full outer electron shell or an empty outer electron shell. So to look at this in terms of ionic bonding, we're going to look at the compound firstly, NaCl, or sodium chloride. So if you're asked a question on this, the first thing you need to do is to take your periodic table and you need to work out the electronic structure of the atom itself. So sodium is here, it says 23 Na11. This means the atom has got a proton or atomic number of 11. It therefore has 11 positive charges. It must have 11 electrons, 11 negative charges to make the atom itself neutral. So our atom of sodium is going to have 11 electrons. And how do we show these? Well, I'm not interested in what's inside the nucleus, so I'm just going to put an Na to tell us that it's an atom of sodium. Our first 2 electrons in sodium are going to be in our first shell here. Okay, our first shell can fit 2 electrons in. Our second shell can fit 8 electrons in. So far I've drawn 10 electrons. Sodium, an atom of sodium has got 11. Therefore I need a third and final shell with 1 electron in it. And this makes sense because sodium is in group 1, which means it has 1 outer electron, so that's correct. Okay, from our definition here, atoms want to bond to get a full or an empty outer electron shell. Sodium is going to want to lose this outer electron, but it can't just, get rid of it. It can't just disappear. It has to go somewhere. Okay, so therefore we need another atom where that electron can be transferred to, and we've said we're going to have sodium chloride. If we look back to our periodic table, chlorine. An atom of chlorine has got a proton number of 17, it therefore has 17 positive protons, and it has also got 17 negative electrons. Okay, so I need to get up to 17 this time. First shell's got 2 electrons in, second shell should have 8 electrons in. That gives me 10. My third shell needs to have 1, 2, 3, 4, 5, 6, 7 electrons in. That gives me 17 electrons in total. Now chlorine atom of chlorine is a bit different. It's got 7 electrons in its outer shell to start with. The easiest way for that to get a full outer shell is to gain 1 electron. Okay, and when it's drawn out of this, it's quite obvious what we need to do. Sodium is going to transfer or donate its outer electron to this atom of chlorine, like so. Okay, we show that electron moving just by drawing an arrow like that. Okay, that is how our reaction happens, how our bonding happens. We need to show what we make. Now, when we're doing this, there are a few tricks to make sure we're going to get full marks. Okay, we're going to start off by drawing our inner shells for sodium, 2 electrons in its first shell, 8 in its second shell. However, now sodium has got rid of this outer electron. It's got rid of a negative charge. Therefore, our atom overall is left with a positive charge. We call this a positive ion, or a cation ion. So this sodium atom here has lost an electron and is turned into a sodium ion. Conversely, our chlorine atom here, which has gained an electron, gained a negative charge, is going to turn into a chloride ion. That's our second shell. Our third shell, 1, 2, 3, 4, 5, 6, 7. They're the electrons that I started with, and it has an 8th electron in the outer shell, which was transferred from the sodium. Because it has gained a negative charge, the overall charge left on this ion is negative. Okay, so this represents the ions in sodium chloride. Now, an ionic bond is actually the force of attraction, or the electrostatic attraction, between these oppositely charged ions. Positive and negative attract, therefore we have forces of attraction between these ions which hold the compound together. So that is a nice simple example. Sodium simply transferred a single electron to chlorine, forming a sodium ion and a chloride ion. We can get a bit more technical though, so we're going to look at a slightly more difficult example, which is going to be magnesium fluoride. So magnesium has got 12 electrons in total, so let's start off by drawing our atom of magnesium. So 12 electrons in total, 2 electrons in the first shell. We change pens. 8 electrons in the second shell, and 2 electrons now in its third shell. So that's our our magnesium atom. Our fluorine atom that we start with has got an atomic number of 9. It's got 9 electrons to start with. 2 electrons in its first shell. 7 electrons in its second shell gives us 9 electrons in total. Okay, this time, if we think about it, this magnesium wants to get rid of its 2 outer electrons. It wants to transfer or donate 2 electrons to get an empty outer shell. However, fluorine only wants to gain 1 electron. So we can start off by showing magnesium transferring 1 of its electrons to fluorine. But this fluorine atom, or the fluoride ion we form, cannot take any more electrons. Therefore, we need another atom of fluorine, which can take the second electron from magnesium. So similar idea, but you need to think about how many atoms of each element we need to be able to make this ionic bonding work. And again, if I draw the ions I form, a magnesium, its inner shells are going to be exactly the same, 2, 8. Okay, it doesn't have an outer shell anymore, or it's got an empty outer shell because it's given away these 2 electrons. This time, we need to think more carefully about the charge it's going to have on it. It has lost 2 pieces of negative charge. The overall charge it's left with is 2 plus, or 2 positive. Okay, for our fluoride ion, it started off with 9 electrons. Each fluoride ion gained 1 electron. So you cannot have more than 8 electrons in this outer shell. Okay, so that is going to be our fluoride ion. Each one has gained a single negative charge, therefore the charge in it is just going to be minus. If you want to draw this out again to show 2 of them, that is absolutely fine. However, it is quicker and easier just to put a big 2 in front of the ion you form in this case. Okay, so this means we had 2 fluorine atoms to start with, and we have formed 2 fluoride ions, each with a single negative charge. Again, our ionic bond is the electrostatic attraction between the positive and negative ions. Using this information, you should hopefully be able to pick any 2, or a metal and a non-metal from your periodic table, and using this similar idea, draw an ionic bonding diagram. So you could, for example, do one for aluminium chloride. Okay, and you should find out, if you draw it all fully, the formula of that should be AlCl3. Okay, so give that one a go, see if you can draw a similar bonding diagram for aluminium chloride.